Hi, this is Julie. In this video, we will learn to use a PV array block in Simulink. When we use library to search PV array, we will see this kind of block is our PV array block, and we are going to use this block in this video. The block looks like this, and it has 2 signal input, 1 signal output, and 2 electric ports. In the version between 2021, the block looks like this, and in 2021 version, the PV array block looks like this. The top input port IR is used to give the irradiance. We can give a constant or a changeable signal to control the irradiance applied to the solar panel. The irradiance unit is watts per meter square, and we can put a value range of 0 to 1,000. The lower one is a temperature control port. Same with irradiance port, you can use a constant or a signal here to control the temperature of the solar cell. The unit of the temperature is degrees Celsius. The measurement port here can give us 5 measurement values during the simulation. They are VPV, IPV, the current on the diode, the irradiance, and temperature. To select the signals, we can use a bus selector to select the measurement value we care. These 2 ports are the electrical port, and it can connect to our electrical circuit. Let's give 1025 as the input of irradiance and temperature to the block as a test of standard test condition. And let's pull out a bus selector, connect to our measurement port. To set the signal in the bus selector, we double-click this bus selector, and we can see that the input signal to this bus selector is this 5 value we just set. And if we want to have this VPV and IPV value, we directly select it and pull it to the right-hand side. This is a selected signal. We select the voltage and the current, as there has a default 2 signals in here, so we just remove it. So this is how to set the bus selector. Now we can see that VPV and IPV on the line here indicate the voltage and current value of the PV. The inside equivalent circuit is same as we discussed in our first video. The only difference is the photon current. It uses IL instead of IPH we used in our last video. And the shunt resistor here is RSH, and we use RH before. When we double click this block, we can set the parameters of this PV array. This first section is to set the array data. This block can also mimic a whole PV array behavior. If a PV array looks like this, it means we have 3 strings parallel together, and on each string we have 2 panels. If the PV array looks like this, the number we should put in here is 3 and 2. But if we're going to simulate 1 PV panel, we should put 1 and 1 here. It means both on the parallel string and series module per string is 1. Then this block can mimic 1 PV panel. The module data part is to set the parameters of the PV panel. You can choose a preset module in the block. There's a lot of PV panels you can choose. Or you can select the top user define, then put in the data according to the datasheet of PV module you want. For example, here I find a PV module online, and this is the datasheet of the PV panel. Here we can see that it has 72 cells, so we put here 72 cells per module, and we need to find the open circuit, short circuit, maximum power point voltage and current. So it should provide it in every PV panel datasheet. If we're going to use this one, the 425 watts, the maximum power point voltage is 42.5. So here is 42.5, and current is 10.01, and the open circuit voltage is 49.8. The short circuit current is 10.67. And by doing so, click apply, it will automatically calculate the maximum power here. To fill in the temperature coefficient of VOC and ISC, we can find the value here. The temperature characteristic. We need to notice that some datasheet doesn't use this kind of unit. So if the unit is not percentage per degree, you need to convert this unit to the same unit as Simulink used. But now this one is same, so for the coefficient of VOC, we use minus 0.26, and the ISC is 0.022. After set the module data, the display part here, can plot the IV and PV characteristic of this panel. We can choose here to set the temperature or irradiance we want to set. For example, if we want plot this kind of plot with same temperature but different irradiance, we need to choose array at 25 degrees, 1000, 800, 600, 400, 200, and by click plot, it will plot the IV and PV curve for us. The last part is this module parameter parts. They are the value of IPH, IS, AN, RH, and RS, corresponding to the parameters we use in our first video. We will use these values in our next video. We also can calculate these values ourselves. If you are interested, I can make an additional video about how to calculate these values. But now we'll just directly use the Simulink calculated for us. When we click Advance, we will meet these two blocks. Preset of break loop time constant is 50 e to the power of minus 6. When we design PV2 converter, our converter frequency is usually up to 100 kHz. This constant is too big for our simulation, so we can change this value to 1 e to the power of minus 6. Here we finish setting the parameters of the PV block. To plot the IV curve of PV panel, we can use a controlled voltage source as the variable load. And to give the control signal of this control voltage source, we use a ramp. Our open circuit voltage is 49.8, where our stop time is 10. So let's set the slope as 5. So at the end of our simulation, the voltage will go to 50 volts. And to measure the voltage and current, we need use the current measurement and voltage measurement, and then collect them together To see the IV curve, we can use a XY graph and connect the voltage at the x-axis and current at the y-axis, and setting the parameter of the scope. The minimum x-axis is 0. The maximum of x-axis is a little bit larger than the open circuit voltage. Y-axis is a little bit larger than the short circuit current, and let's set as this. By doing so, when we run it up, never forget when we do this electrical simulation, we need to use Power GUI. And when we click run, we will get this IV curve from our XY graph. Or if we want to know the exact value of the voltage and current, we can use this 2 workspace block to save the value of current and voltage to the workspace. Change the name and set the save format to structure with type, and we will see this output is saved in our workspace, and in this structure we can see our current and voltage value is saved inside. We can use this code to plot the IV and PV curve like this. So this is the same with what we did using XY graph. But by using this way, we can save our value of voltage and current. In this video, we learned to set the parameter of PV array block to simulate PV source in Simulink. In next video, we will build a PV source model, use basic Simulink block, and can produce same PV output characteristics like this one. So thank you for your watching. We will see you in next video.